Momentum. The formula to find momentum is mass times velocity, or P equals mv. Momentum is a vector, meaning it has magnitude and direction. The unit used for magnitude is kilograms times meters per second. The total momentum before and after a collision stays the same, which is the law of conservation of momentum. In order to have momentum, the object must be moving. Also, the more a mass an object has, the more momentum it has.
Person A's velocity is 0 meters per second. Their mass is 50 kilograms. Because of this, their momentum is 0 kilograms times meters per second. Person B's velocity is 5 meters per second. Their mass is 40 kilograms. Because of this, their momentum is 200 kilograms times meters per second.
There are three types of collisions. The first is elastic, where objects collide and bounce. The second is inelastic, where objects collide and stick. The third is an explosion, where the objects push apart.
Person B collides with person A, and they both bounce. This is an elastic collision.
Before this collision, person A has a mass of 50 kilograms, a velocity of 0 meters per second, and a momentum of 0 kilograms times meters per second. Person B has a mass of 40 kilograms, a velocity of 5 meters per second, and a momentum of 200 kilograms times meters per second. Their total momentum, which is the momentum of person A plus the momentum of person B, is 200 kilograms times meters per second. After the collision, person A still has a mass of 50 kilograms, but now has the velocity of 2 meters per second and a momentum of 100 kilograms times meters per second. Person B still has a mass of 40 kilograms, but is now moving at 2.5 meters per second and has a momentum of 100 kilograms times meters per second. Their total momentum after the collision is still 200 kilograms times meters per second.
Person A and B collide and stick. This is an inelastic collision.
Before this collision, person A has a mass of 50 kilograms, a velocity of 0 meters per second, and a momentum of 0 kilograms times meters per second. Person B has a mass of 40 kilograms, a velocity of 5 meters per second, and a momentum of 200 kilograms times meters per second. Their total momentum is 200 kilograms times meters per second. After the collision, the mass of person A and person B are combined and is now 90 kilograms. The velocity is slower, now at 2.22 meters per second, and now the total momentum is still 200 kilograms times meters per second.
Person A and person B are stuck together and they push apart. This is an example of an explosion.
Before this collision, person A and person B together have a mass of 90 kilograms, a velocity of 0 meters per second, and their total momentum is 0 kilograms times meters per second. After the explosion, person A has a momentum of 40 kilograms, a velocity of negative 6.25 meters per second, and a momentum of negative 250 kilograms times meters per second. Person B has a mass of 50 kilograms, a velocity of 5 meters per second, and a momentum of 250 kilograms times meters per second. Since person A is moving to the left with the same momentum as person B, who is moving to the right, their momentums are opposite and therefore cancel out. This leaves their total momentum after the explosion still at 0 kilograms times meters per second, even though they are both moving.
The law of conservation of momentum is proven. In all three situations, the total momentum before and after each collision stayed the same.